pursuing BE in Electronics and Communication in Sri Venkateswara College of Engineering. I am from 3rd semester. Today my subject is Computer Organization and Architecture, and the topic is Types of Memory, that is SRAM, DRAM and Flash Memory. Let us see about the SRAM, DRAM and Flash Memory. Semiconductor RAM memory is internal organization of memory chips. Memory cells are organized in the form of array as shown in figure 8.2. This is the figure of organization of bit cells in a memory chip. Each cell is capable of storing one bit of information. Each row of cells forms a memory word. All cells of a row are connected to a common line called as word line. The cells in each column are connected to sense or write circuit by 2 bit lines. The sense or write circuits are connected to data input or output lines of the chip. During a write operation, the sense or write circuit receive input information and store input info in the cells of the selected word. SRAM, Static Random Access Memory. Memories consist of circuits capable of retaining their states as long as power is applied or known. Two inverters are cross connected to form a latch as shown in figure 8.4. This is the figure of a static RAM cell. The latch is connected to 2-bit lines by transistors T1 and T2. The transistors act as switches that can be opened or closed under the control of the word line. When the word line is at ground level, the transistors are turned off and the latch retains its state. Let us see about the read operation in SRAM. To read the state of the cell, the word line is activated to close switches T1 and T2. If the cell is in state 1, the signal on bit line B is high and the signal on the bit line B is low. Thus, B and B double dash are complement of each other. Sense or write circuit monitors the state of B and B double dash and sets the output accordingly. Write operation in SRAM. The state of the cell is set by placing the appropriate value on bit line B and its complement on B double dash and then activating the word line. This forces the cell into the corresponding state. The required signal on the bit lines is generated by sense or write circuit. Let us see about the CMOS cell. Transistor pairs T3, T5 and T4, T6 form the inverters in the latch as shown in figure 8.5. This is the figure of CMOS memory cell. In state 1, the voltage at point X is high by having T5, T6 on and T4, T5 are off. Thus T1 and T2 return on closed. Bit line B and B double dash will have high and low signals respectively. So let us see about the advantages and disadvantages. Advantages: it has low power consumption. The current flows in the cell only when the cell is active. Static RAMs can be accessed quickly. It access time in few nanoseconds. Disadvantages: SRAMs are said to be volatile memories. Their contents are lost then when power is interrupted. Let us move on to the dynamic random access memory, DRAM. Less expensive RAMs can be implemented if simple cells are used. Such cells cannot retain their state indefinitely. Hence, they are called as dynamic RAM or DRAM. The information stored in a dynamic memory cell in the form of a charge or a capacitor. This charge can be maintained only for tens of milliseconds. The contents must be periodically refreshed by restoring this capacitor charge to its full value. In order to store information in the cell, the transistor T is turned on, as shown in figure 8.6. This is the figure of a single transistor dynamic memory cell. The appropriate voltage is applied to the bit line which charges the capacitor. Asynchronous DRAM description. The 4-bit cells in each row are divided into 512 groups of 8 as shown in figure 5.7. This is the figure of internal organization of 2M into 8 dynamic memory chip. 21-bit address is needed to access a byte in the memory. 21 bit is divided as follows. 12 address bits are needed to select a row, that is A8 to 0, that specifies row address of a byte. 9 bits are needed to specify a group of 8 bits in the selected row, that is A20 to 9, that specifies column address of a byte. During read or write operation, row address is applied first. Row address is loaded into row latch in response to a single pulse on RAS input of chip. RAS means row address strobe and CAS means column address strobe. When a read operation is initiated, all cells on the selected row are read and refreshed. Shortly after the row address is loaded, the column address is applied to the address pins and loaded into CAs. The information in the latch is decoded. The appropriate group of 8 sense or write circuits is selected. R var W dash is equals to 1. Read operation. A dash output values of selected circuits are transferred to data lines D0 to D7. R bar W dash is equals to 0. That is write operation. A bar information on D0 to D7 are transferred to the selected circuits. RAS and CAS are active low so that they cause latching of address when they change from high to low. To ensure that the contents of the DRAMs are maintained, each row of cells is accessed periodically. A special memory circuit provides the necessary control signals RAS and CAS that govern the timings. The processor must take into account the delay in the response of the memory. So let us move on to the flash memory. In EEPROM, it is possible to read and write the contents of a single cell. In flash device, it is possible to read contents of a single cell and write entire contents of a block. Prior to writing, the previous contents of the blocks are erased. For example, in MP3 player, the flash memory stores the data that represents sound. Single flash chips cannot provide sufficient storage capacity for embedded system. So, advantages of flash memory are flash drives have greater density which leads to higher capacity, low cost per bit. It requires single power supply voltage and consumes less power. There are two methods for implementing larger memory. First one flash cards and the second one flash drives. On the way of constructing larger module is to mount flash chips on a small card. Such flash card have standard interface. The card is simply plugged into a conveniently accessible slot. Memory size of the card can be 8 to 32 or 64 MB. For example, a minute of music can be stored in 1 MB of memory. Hence, 64 MB flash cards can store an hour of music. And the second one, flash drives. Larger flash memory can be developed by replacing the hard disk drive. The flash drives are designed to fully emulate the hard disk. The flash drives are solid state electronic devices that have no movable parts. So let us see the advantages and disadvantages of flash memory. They have shorter seek and access time which results in faster response. They have low power consumption. They are attractive for battery driven application. They are insensitive to vibration. Disadvantages are the capacity of flash drive is less than the hard disk. It leads to higher cost per bit. Flash memory will be weaker after it has been written a number of times, typically at least 1 million times. Thank you for watching.